This slideshow is the first slideshow of chemical reactions. Let's move to the next slide. What is a chemical reaction? Chemical reaction is a process in which substance or many substances is or transferred into one or more new substances. Typically, when chemical reaction happen, you notice. So, what is a chemical equations? Chemical equation is you going to translate a process of chemical reaction into chemical symbols. The chemical symbols that you learned in the previous chapter, chapter 2 and chapter 3. Let's move to the next slide. So in this slide, your goal is to be able to translate the observations or description of the chemical reaction into chemical symbols. Let's move to the next slide. So here, the observation or description of chemical reaction is potassium and bromine reacts and produce potassium bromide. That's the observations or description of chemical reactions. You want to translate this observation to chemical symbols. Potassium. How do you write potassiums in a chemical symbols? It's simply the element symbols K. And bromines. How do you write bromines? The bromine is, remember, bromine is made of molecule. It's made of diatomic molecules. Therefore, you would write it down Br2. And it is not Br or Br3 or Br4, for example. You need to know bromine is Br2. Remember, I asked you to know 7 elements. There's 7 elements that occurs as diatomic molecules. Hydrogen is H2. Nitrogen is always N2. Oxygen gas, O2. Fluorine gas, F2. Chlorine gas, Cl2. Bromine is actually liquid at the room temperature. Bromine, Br2. And iodine, which is I2. So that's the bromine. And you produce potassium bromide. How do you write potassium bromide? You need to know it should be KBr. It's not the KBr2 or it's not K2Br. Once you write it down, the observations to chemical symbols, now you need to look at both. You need to look at the both sides of the reactions, chemical equations. Left-hand side, make sure left-hand side and right-hand side has the same number of elements for each element. For example, in the left-hand side, you should have same number of potassium and same number of potassium on the right-hand side. Therefore, you need to include 2 in front of the potassium, and also you need to include number 2 in front of potassium bromide. So when you look at the equations right now, you see that there is right now potassium, there is a 2 potassium, and also you have 2 bromine element. Because of the subscript 2, you should see that there is a 2 bromine. When you move to the right-hand side, because of the 2 in front of KBr, there are 2 potassium and you have 2 bromine. Therefore, the number of the elements for each element are the same on left-hand side and right-hand side. Let's move to the next slide. Next reaction is hydrogen gas react in air which contains oxygen gas to form water. So here reactant is hydrogen gas and oxygen. And again, you must know hydrogen gas is always H2. It is not H, or it is not H3. You must know oxygen gas is O2. It is made of O2 molecules. It is not O, or it is not O3. And we know water is H2O. Again, you need a number in front of chemical symbols. For example, 2 in front of hydrogen, H2, and 2 in front of H2O. Now, left-hand side, you have 4 hydrogen, and you have 2 oxygen. Right-hand side, you have 4 hydrogen and 2 oxygen. Therefore, the number of the elements for each elements are the same on the left-hand side and right-hand side. The number in front of chemical formulas are called the stoichiometric coefficient. So when in a chemistry textbook says stoichiometry or stoichiometric coefficient, they are always referring to the number in front of chemical symbols or chemical formulas in a chemical equations. In this example, 2 in front of the H2 is a stoichiometric coefficient. Also, in front of the oxygen, O2, if there's no number written, you always assume the number is 1. And the 1 is also stoichiometric coefficient. And also 2 in front of H2O is stoichiometric coefficient as well. And this stoichiometric coefficient represents the number ratios in the reactions. For example, simply in this case, what does that mean? It means if you have 2 hydrogen molecules and 1 oxygen molecule, you will produce 2 water molecules. So this stoichiometric coefficient are the number ratios. It is not the grams or it is not the volume. It's simply the numbers. And also, you should know that stoichiometric coefficients are not always conserved. So let's just focus on the stoichiometric coefficient. Left-hand side, you have the 2 in front of hydrogen, H2, and 1 in front of oxygen. When you add 2 and 1, you get 3. You get 3 on the left-hand side. You move to the right-hand side, you look at the stoichiometric coefficient, which is 2. So as you see, the stoichiometric coefficients are not conserved. Left-hand side and right-hand side, they can have the different number of stoichiometric coefficient. In other words, in the left-hand side, you have 3. You have right-hand side, you have 2. And that's okay. So what need to be conserved is, again, it's the number of elements. For each element need to be conserved. In this case, again, you have the 4 hydrogen elements. And you should have 2 oxygen elements on both sides of the equation. Let's move to the next slide. Here, the observation is magnesium and carbon dioxide react and produce carbon and magnesium oxide. How do you translate this observation into chemical symbols that you learned previously? Magnesium should be simply magnesium element symbols, Mg. Carbon dioxide, CO2, and produce carbon. Carbon is C, and magnesium oxide is MgO. Again, once you translate observation into chemical formulas, you need to balance. The technical term you use here is a balance. You need to balance chemical equations so that the number of elements for each element are the same on both sides of the equations. Therefore, you need a 2 in front of magnesium, and then you need a 2 in front of FgO. This is the end of the slideshow number 1.